Hi everyone, Grant for the Flame Learning channel. In this video, you'll start learning all about the new 3D camera tracking tools in Flame 2022. This new technology uses simultaneous localization and mapping techniques, better known as SLAM 3D tracking, and it should help you tackle most 3D tracking challenges directly in Flame. This could be adding objects into a scene, cleanup work with projections, set extensions, and more. This works in all color spaces, provided that your tracking plate is correctly tagged and color managed. And like all 3D trackers, the camera needs to be moving in the shot, and any parallax will definitely help solve the camera's movement. If you're locked on a tripod, simply panning or tilting, then you should be using some of the other tracking tools in Flame. So consider this video as your high-level introduction into the new 3D tracking, and the upcoming videos will dive deeper into the toolset and showcase various scenarios. So here you have a 75 frame shot, and you would like to add some objects into the scene. The shot is already loaded into batch, so you can grab an action node and connect your clip as the background. I'll be using a 2-up view to help explain what's happening, but you can use any viewing configuration you want. Now to start, there is a new tool called Camera Analysis. This is located in the Action Node bin and your Schematics right-click menu. This is what performs your 3D tracking, and its data must be fed into your 3D camera. So when you're about to start a 3D track, you would select your camera node and then add your camera analysis. This selection creates a mimic connection to the selected camera, and it's ready to receive any 3D tracking data from the camera analysis. If you have not created this connection, you could do it manually with Mimic Link, or later on in the camera analysis menus. Now I'm sure you have also noticed the motion vectors map, which is essential for the camera analysis. You should not need to touch or delete it while 3D tracking. Now the camera analysis has its own set of menus as you would expect. But the other big component to use it is the camera analysis views. In fact, you have 3 of them. You have the scene view, the camera view, and the media view, and each one has a specific purpose. With the camera analysis node selected, you can cycle through the views using the F8 keystroke. So the first view you should always start with is the media view. You can tell what you're looking at by looking at the description in the viewport. The media view shows your footage and any initial tracking points as you set up for the track. Returning to the menus, it's now time to set up the relevant camera and tracking data. Now knowing everything about the original camera setup will definitely help with your 3D track. The main value you are after is the camera's field of view, or FOV. If you don't know that, you use the static mode, and the camera analysis will calculate the FOV for you during the 3D track. You could enter an approximate FOV to help, but camera analysis locks in the FOV and uses it for every frame. The dynamic mode is the same as the static mode, except the camera analysis will recalculate the FOV for each frame. This is necessary if you're zooming while moving the camera. Finally, if you know the field of view, switch the mode to fixed and enter the FOV in degrees. This locks in the value no matter what. If you don't know the FOV but do know the lens's focal length and camera sensor's height, you can enter in these values and the FOV will update. Since you don't know much about this shot, you'll use static in this case, and Flame will work out the FOV. The final step before analyzing the shot is setting the resolution of the track and the number of trackers per frame. Resolution refers to the quality of the track, where a value of 1 tracks every frame, giving you the most accurate track possible. Decreasing the resolution skips frames for a less accurate track, but it's great for quickly testing the camera analysis on your shots. You can always set the resolution back to 1 when you're happy and redo the analysis. Now 3,500 trackers per frame sounds quite a lot, but you can add more or less trackers per frame depending on the level of detail in the image. This value can't be changed after the initial analysis, so you would need to reset the camera analysis to try again. Lastly, the camera analysis requires a reference frame as a starting point for the 3D track. Ideally, this frame should show the most detail without any motion blur or occlusions. By default, the reference is automatically set to the first frame of your shot. If that is mostly the case, you don't need to press the Set button and you can analyze straight away. However, if you want to use any other frame as the reference, you would go to that frame and press the Set button before the analysis. Now go ahead and click Analyze. Once the camera analysis completes, the media view fills with all the tracking points. As you scrub the time bar, you can see how the tracking points are locked to the shot. This is a good place to see if any trackers are slipping as a result of the camera analysis. Now let's have a look at the point cloud. Toggle the camera analysis view to Scene View. Here you can see the camera moving through the scene. If you orbit around the point cloud, you can make out the objects within the scene, such as the chairs, table, bookshelf, sofa, and the walls. So you are able to see where objects could be placed in 3D space. It is also possible to tweak and refine the track in this view, but more on that in later videos. Right now, let's toggle the camera analysis view to Camera View. So this is what the camera analysis will be feeding to the main camera in the Action 3D space. Similar to the media view, you can scrub the time bar, see the point cloud move in the scene, and identify if there are any issues. This is super cool, and in the upcoming videos, you'll cover areas such as tracking refinements, validation, origin points, ground planes, etc. Now before this video concludes, let's use this data to integrate objects into the Action 3D composite. So the camera analysis is already feeding the camera movement into the Action 3D camera. This is because of the mimic link between the nodes. If you created the camera analysis without the mimic link, you can click the Link to Camera in the Camera Analysis menu. So the camera move is taken care of. In terms of the point cloud, you can choose which points you'd like to use within the 3D composite. For example, you'd like to cover those photo frames with a flat screen TV. Selecting one point will give you the position in 3D space, and that's it. But selecting multiple points will give you the average position and attempt to match the perspective of the wall. Click Scene Trackers, and the newly created axis will align itself with an XY orientation. XY orientation is easily understood as standing up, and XZ orientation is considered as lying down. This is all about initial alignment, but you can always change it after the fact. To tweak the alignment of the axis, switch the 3D manipulator to object mode, and using the rotate tool, you can adjust the grid plane until you're happy with the alignment. Please note that you did this in the camera analysis camera view so that it could be matched up with the point cloud. You could even line the plane up in the scene view just to confirm the positioning. Once this is complete, you can return to the action result view, and there is your axis in the 3D composition. If you wish to hide the axis plane, go to the axis menus and disable the plane under the display controls. Now let's bring in our new TV. Go back to Batch and add a new media input into Action. Returning back to the composite, the new object is floating in the middle of the 3D composite. To snap the TV against the wall, connect the tracker's axis to the new object. Now you may want to adjust the position, orientation and size of the TV, so use the object's axis sliders to move, rotate and scale the TV. You can also use the 3D manipulator in object mode to adjust the object directly in the result view. When you scrub the time bar, you can see how the TV sits comfortably on the wall and tracks happily with the rest of the shot. So hopefully this overview of the camera analysis has given you the standard workflow of performing a 3D track in Flame. In the upcoming videos, you'll start focusing on the details of the tools as well as various workflow challenges that you'll encounter with everyday 3D tracking. Please subscribe to the Flame Learning channel and click the bell to be notified for future videos. Comments, feedback and suggestions are always welcome and appreciated. And thanks for watching.